Now we are working on Chapter 3, Problem 21, Part B. Consider the triangle formed by the area of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall.
Now we are finally done with Part A and we're going to be moving on to Part B. So for Part B, we basically take what we did for the first one in Part A and help us to solve this one. So we're going to start with step 1. We just sketch, and we're going to take all the information that we have from Part A when we found the 7 feet and use it here. So I'm going to draw my triangle out, got my house, got my ladder, and I have my base. Now, from what we have learned, we know that our Z is 25 feet. We know that this is going this way by 2 feet per second. And we know our base, which is our X. We also know this is the XDT now. We know that our X is 7 feet. Now the rest of the information, we also know our dZdt equals 0, and we know that our Y, from when we solved it in the Part A, that our Y is 24 feet. So our Y is now, and we also figured out our dy dt when we were solving, and we know that it's going this way, which makes it negative, and so our dy dt equals negative 7/12. Okay. So this is basically part of step 2. So step 2 is going to be a lot easier than what it was last time. So we have step 2. Our equation. Okay, so since we are finding the area, and we have a triangle, the area of our triangle is A equals 1/2 base times height. So to note, which is a very important note, I'm going to kind of keep it on the side over here, and I'm going to write in this brown one. We need to note that our base is what we say for our X value. And our H, which is our height, is our Y value. So that'll make it a little bit easier to understand once we put it in here. So now we know our B is equal to 7 feet, and our dB dt, so I'm going to change this to a lowercase b since the base is a lowercase b, is the same thing that we have up here, which is 2 feet per second. So we're basically changing everything that says X will be B, everything that says Y will be H. So we have our H equals 24 feet, and our dH dt, which we solved in Part A, is negative 7/12 feet per second, which I forgot to put here. When you're writing, make sure that you put all your variables and all the units next to it. Now we are looking for our dA dt, which is our question, because we are trying to find the rate in which the area is changed based off time. And now we'll be moving on to step 3. So our equation is area is 1/2 base times height. Now to derive it, we're going to derive both sides. So we get d dt times a equals 1/2 times base times height times d dt. Okay, so for this one, we're going to have dA over dt equals, and for this, we're going to keep this the same because it's basically a constant, so we're going to have our 1/2 on the outside. Then we are going to take this portion right here and do chain rule. So when we do that, we get, not chain rule, this is product rule, my bad. So when we do that, we get our base times the derivative of the other one, which is dH dt, plus, we keep this one the same, times the derivative of b, which is dB dt. Okay, so this is now our derivative. And so then we will be moving on to step 4, which is the easiest step. Okay, so now we'll be plugging and chugging. Since we're looking for dA dt, I'm going to keep this in black. Since 1/2 is staying the same, I'm going to keep that black. And now it's where the colors are going to come a little bit useful. Here is B, and here is dB dt. Here is dH dt, and here's H. So now I'm going to take it, and I'm going to say our 7 feet, do not forget your units, times our -7 over 12 feet per second, plus our H, which is 24 feet, times our dB dt, which is 2 feet per second. That's one whole thing. All right, and now we're going to simplify until we get an answer. So I'm just going to use a black marker to simplify a little bit. So we have dH dt equals 1/2. And then I'm going to say -7 times 7 is 49. So I'm going to have -49 over 12 feet squared per second, plus 24 times 2 is 48 feet squared per second. The reason it is squared is because I have a feet times a feet. And now what I'm going to do is make it so they have the same denominator. Okay, so we're going to keep the ADT the same. We're going to have it equals 1/2. We're going to keep this the same as well. And say -49 with 12 feet squared per second. And we're going to times the top by 12 so we can have a bottom by 12 as well. And we'll get 576 over 12 feet squared per second. That way we can subtract these with no problem. Now we have dA dt equals 1/2 times 527 over 12 feet squared per second. And now what we do is we're going to times our bottom denominators together. We get dA over dt equals 527 over 24 feet squared per second. And that is our final answer.